Welcome back, and in this section we're going to look at DICOM and its relationship to image acquisition. So far we understand that there are modalities, and these are the image acquisition devices. So the modality is generating the image. If we think back to earlier on in our discussion, we understand that the image is sometimes referred to as a payload that goes inside of the DICOM container. Now, similar to when we were talking about payload and with cargo and delivery, we have these containers that have very useful labeled information on the outside. It tells us where it's going, what's inside. And this labeled information is structured in such a way where it would follow, we'd have to put the information in its appropriate place. We can't just label it as we see fit. And DICOM is very similar to this. We have a specific DICOM hierarchy of where we would be expecting to insert certain valuable pieces of information. At the top of this hierarchy, we have the subject, which is the patient that is receiving the imaging. This patient is going to have at least one study, one or more studies, imaging studies associated with them. The study itself, if we zoomed in on that, this is a collection of imaging sets that are related to a specific diagnostic request that was ordered. That study is going to have at least one series, one or more series. Now, if we zoom into the series, we're going to see a subset of instances bound by a type of imaging and a general point of time. So a set of instances, or for the purpose of this part of the conversation, let's just think of those as images. So within the series, we have a number of images that are bound by the time period that they were taken in or the angle that they were taken in, and this compiles the series. Now, if we zoom in a bit closer, and we're going to look at one of those images, this is the specific binary payload, the actual DCM file itself, but within that, we could have something where there's frames. We talked about this within ultrasound, where you could be doing like a cardiac ultrasound and you're watching the heart over a time period. So it's one single image that's captured, but you could have multiple frames within that, which is down below. And we also have MPO, which is where we're going to have non-patient information, such as color profiles and other types of protocols. But what this hierarchy allows us to be able to do is have a very clean modular organization when it comes to DICOM. But essentially these DICOM attributes, they're conveniently grouped into modules, and they enhance the clarity and usability of medical imaging data. We talked a bit before that within the way that we identify modalities, there is a specific DICOM standard for every single modality code. So if I'm looking at this DICOM tag, I can see that the modality is CT, and that is the defined DICOM tag for computed tomography. And if I wanted to explore this further, I can go on the DICOM website and I can see a full comprehensive list of all of their modalities. And so some of these might be the traditional or more common ones that we touched on in our image acquisition section around modalities. And some of these might be beyond radiology, where we're seeing image acquisition devices, like there is XC for external camera photography. So we can see that we're thinking of image acquisition or modality devices from a standard DICOM perspective that are beyond just radiology at this point. Now, I did reference earlier this word instance when we were going through that hierarchy. And just below series, I referred to that the series is a subset of instances. And I didn't say images. And the reason for that is at that DICOM binary level, where we're having the actual file itself, there are times where it could be an image. It often will be an image. But there are times where there are non-image DICOM objects. So examples of this are where we have things like a scan document. So the patient is scanned on the modality. There are some notes that have been captured, perhaps in paper, and that's going to be scanned in as a separate document. It's not really part of the imaging set. It's not a diagnostic image, but it's a scanned representation. And you would also have an opportunity where if we're looking at modalities that have ionizing radiation, we may want to capture the dose that's coming out of that. We're going to touch on that a little bit more in another section. But when we look at the opportunity of capturing that, there are these items called DICOM structured reports that allow us to be able to receive the information about the dose that was emitted, but this is not an image file. This is not an image instance. This is a structured report. There's also things like presentation states. And this is where, when we're a radiologist and we're looking at the image and say we're applying measurements and we're writing notes and we've got our region of interest identified, all of these are markups. And often they are, historically, they were defined in a proprietary way, meaning if I create my markups in my local packs and I share this with the neighboring hospital, those markups are not going to be shared. So presentation states are the standard method of being able to share those in a non-proprietary way. And we have these presentation states where I can have the image itself, and I'm applying markups and so on. And I'm going, as I'm creating my rulers and my markups, I'm going to be generating additional presentation states that reference this image. They are not an image themselves. They would be identified as a presentation state. And then finally, there's a key object. And these are where, an example of this is where we could be using this for quality control or change management. It's not uncommon that we have scanned the patient, we have sent the images to the PACS, and we realize that 5 of those images need to be deleted. And this is where key objects can come in using IOCM, which is a profile called Image Object Change Management. We'll touch on that later on, but key objects allow us to communicate some of those changes to say 5 images have been deleted. We're not actually sending an image to inform that. We're just sending a non-image object type called a key object to inform that update. And these can be generated by the modality themselves. They can be generated at the clinical workstation, the PACS RIS workstation. But these are a common thing that we'll encounter at that instance level. So most of the time, a study will primarily have the majority of images, but we should expect to see non-image object types as well. And when we are capturing these are all going to hopefully end up resulting in getting archived successfully to the PACS, and we want to make sure these are important document items that are going to inform and potentially modify how the image is displayed. It's important that these non-image object types are archived and fully available as part of the study. Now, when we just think of how these are instances, they actually do have their own modality code. Key objects are identified as a KO in the DICOM modality code. A presentation state would be identified as PR. Structure report is SR. And in often those cases where we're scanning a piece of paper in, the documentation code or the DICOM modality code would often be OT. Now, this gives us a sense of how the metadata is being compiled. Now, if we pivot a little on the DICOM side and we think about the image itself, it's important for us to reacquaint ourselves with a couple terms here. So, pixels and voxels. The pixel is the fundamental unit of a digital space that represents a single point in a 2D space. So we're probably very familiar with this. If we think of this in the context of medical imaging, we would have each individual pixel that is making up the entirety of a digital image, like a building block, so to speak. Now, the voxel, this is an extension of this pixel concept, but thinking of this from the 3D space. So the voxel represents values on a regular grid in 3-dimensional space, much like a 3D pixel. So we'll acquaint ourselves with this idea of pixels and voxels. And again, that idea of the building blocks of pixels. So we have mosaics that come together, each individual stone being placed in the right way to create these beautiful mosaics. And similarly so, we have this idea of the building blocks of each pixel being formed, and we want to make sure that it's rendered properly and each one is displayed, so we have this beautiful, we ultimately have this nice display of a medical image in front of us. Now, the DICOM attributes play a very important role in ensuring that we can successfully store, exchange, and display this imaging payload. Now, if I wanted to recreate or remaster an original painting, so I have the screen here, and I want to make a copy of this as closely as I can, I would be looking for things like what were the exact color representations that were used? How were the brush strokes? And I want to be able to copy those. Now, when it comes to DICOM, these DICOM attributes are responsible for pixel data encoding in that same way. So the attributes are going to allow us to be able to get all that information that we need so we can recreate this medical imaging masterpiece on the other side. Now, on the DICOM attribute side of things, there is this important tag. So the photometric interpretation attribute, this allows us to specify how the pixel should be interpreted and displayed as either grayscale or color. So if we think of this as an example of some of the modalities that we've encountered or gone through already, let's think of this as a plain film chest x-ray. And if we're going through plain film, let's look at this from a couple examples of modalities that we've already looked at. So if we were looking at a plain film chest x-ray, the photometric interpretation is very likely to be monochrome 2, which would indicate that we have this grayscale palette that's going to be allowing us to render the images in its appropriate way. It's very possible for ultrasound, especially cardiac ultrasound, where we're going to have some color in there. And the photometric interpretation value for an ultrasound that has color could be RGB. And there's some variations on this. You'll typically see monochrome 1 or monochrome 2 representing gray, and there's some different variances that can represent color. But it's important just at this point for us to understand photometric interpretation is the attribute that's allowing us to be able to distinguish some of these. And there's many attributes that allow us to be able to decipher and determine and render the image in a successful way. So in this section, we looked at the DICOM hierarchy, where there is a single patient that sits at the top. That patient would have one or more studies associated with them. The study would have one or more series within it. The series is a collection of instances over a period of time or from a general area or perspective. That if we zoom into the instance typically represented as an image, but not always, could have frames within it. We understand that there are non-image object types. Examples of this are scan documentation, presentation states, key objects, and structured reports. We also understand that the DICOM attributes play a significant role when it comes to encoding how color versus grayscale imaging is rendered. So with all that said, let's get ready for the next section, image acquisition across the enterprise.